Hey guys, welcome to your 6-2 notes on solving systems using substitution. By the end of the day, you'll be able to solve systems of equations by using, wait for it, substitution. So remember that in order to find a solution of an equation is, a system of a solution of equations is any ordered pair. And by ordered pair, what I mean is like an XY combo. So you've got your X value for your variable, your Y value, that makes both equations true. Not just one, but both equations true. Okay. This is going to represent a point that lies on the line. So it really is the XY value of a point lying on both lines. So yesterday we looked at graphing. Now we're going to look at the substitution method. And how the substitution method works is you're going to take one value of a variable and plug it into the other equation. So in order to do that, you first need to solve one of the equations for just one of the variables. We often solve for y. You can solve for x if it makes your heart smile. After that, you substitute that value into the other equation. Then you'll solve for what that other variable is, and then finally you can write the solution as an ordered pair. So that's the key idea. Know it, memorize it, love it, put it into practice. Let's put it into practice right here. I'll show you what to do. So first, as you can see, these are already solved for y. I know that y equals 2x plus 7, and I know that y equals x minus 1. So I'm going to start out with the concept of y equals y. You agree with that statement, right? Y is equal to y. Well, up here, I know that y is 2x plus 7. So I'm going to, instead of y, I'm going to write 2x plus 7. And that's equal to y. But on the other hand, I also know that y equals x minus 1. Y equals x minus 1. So now I have each of these guys, and I'm going to say that they're equal to each other because 2x plus 7 equals y, ta-da, and x minus 1 equals y, ta-da. I know that since they're each equal to y, they are equal to each other. Now I have this equation, and all I'm going to do is I'm going to solve for x. So I'm going to try to get x all by itself. The first step is I'm going to get all the x's on the same side, which gives me x plus 7 equals negative 1. And then I'm still trying to solve for x, so I'll subtract 7 from both sides, giving me that x equals negative 8. Yay, x equals negative 8, cool! But we're only halfway done because we know what x is. So in our solution, we need an x value, yes, awesome. We also need a y value. How are we going to figure out, once we know that x equals negative 8, how are we going to figure out what y is? Fortunately for us, we have not one but two equations that tell us how to find y. As long as we know x, always go with the simplest one. So we're going to take y equals x minus 1 and replace this x with what we know x to be. We know x is negative 8. So that tells us that y equals negative 8 minus 1. Negative 8 minus 1 is in fact negative 9. So y is negative 9, which means the solution to this equation is negative 8, negative 9. We check our answer by plugging it into both equations. So for our first equation, we had y equals 2x plus 7, and our second one, we had y equals x minus 1. So we're going to plug our values from our points in for our variables right here. So in this point, are you trying to tell me that negative 9 equals 2 times negative 8 plus 7? Is that true? It's a question mark. Well, is negative 9 negative 16 plus 7? Yes, that's true. So it works for one of them. Are you also trying to tell me that negative 9 equals negative 8 minus 1? Well, yeah, that's true too. So yeah, we did it right. Good job. Now this one was pretty straightforward because both of the equations were already solved for y. They already had y all by themselves. Sometimes you don't have that, but you can have an equation that can be solved easily for one of the variables. So if that comes easily to you, you can use the substitution method. For example, in this case, it's not solved for y. We don't have something solved for y or for x. But I look at this guy down here, and I can really easily solve for y right there. So I'm going to do that real quick. I'm going to take this equation. I'm going to add 2x to both sides because I'm trying to get y all by himself. Our x's cancel out. That leaves us with y equals 2x minus 3. So if y equals 2x minus 3, I can take this and I can substitute it back into the first equation because I know that y equals 2x minus 3. So let's do that. That gives us 3 times 2x minus 3 plus 4x equals 14. Again, the original equation was 3y plus 4x equals 14, but I substituted my value for y. Now let's simplify it. My first step is going to distribute this 3. I'll use blue. Is going to distribute this 3 into here, which gives me 3 times 2x minus 3 times 3. Yeah, 3 times 2x minus 3 times 3 plus 4x equals 14. Simplifying gives us 6x minus 9 plus 4x equals 14. Then I'm going to see my two x's and I'm going to combine like terms, giving me 10x minus 9 equals 14. Then I'll add 9 to both sides, giving me 10x equals 23. Finally, to figure out what x is, I can divide by 10 on both sides. So x equals 2.3. Cool. Again, that's only half of it. I know what x is, so in my solution I can put 2.3 for my x. Now we need to figure out what is our y. Well, fortunately for 2s, we have not one but two equations to help us figure out what y is. I'm going to go ahead and use that second one again. That second one just seems easier. But the first one doesn't have any negatives. That's pretty attractive. You know what? Let's go with that one. So we have 3y plus 4x equals 14. Now that we know what x is, we're going to substitute 2.3 in for x, which gives us 3y plus 4 times 2.3 equals 14. By the way, does it matter which equation you use to plug x into? No, it doesn't. It really doesn't. So go ahead and use whichever one you think is nicer. 3y plus 4 times 2.3 is 9.2 equals 14. So yay. And then we're going to subtract, we're going to subtract 9.2 from both sides, giving us that 3y equals 4.8. Finally, to get y all by himself, we'll divide both sides by 3, so y equals 1.6. Now we've got our x, we've got our y. To save you some time, I already plugged it into both equations and it does work. So, yay. We got it. Good job. Okay, that's great, but when are we going to use this in real life? Well, let's say that at softball games, the Lady Herald snack bar sells 2 sizes of snack packs. You've got a large snack pack, and that costs $5, and you've got a small snack pack that costs $3. In one day, the large snack bar, there's only one. The snack bar sold 60 snack packs for a total of $220. How many types did they sell? Well, there are 3 steps to this problem. First, we need to define our variables. We need to say what our x and y are going to be. And then after we define our variables, we can write a system of equations to help us solve this problem. We can model the problem with equations. And then finally, we will actually solve that system. Oops. Solve. Okay, so the question asks how many of each type did they sell? So we're looking for an equation, or actually two, that tells us how many of each type. So that's what our variables should represent. Let's let x, since that's the order that they give us, we have large first, they need to answer how many. We need an answer to how many. Okay, so x is going to answer how many large snack packs we have, and y is going to answer how many small snack packs we sold. Just to have all the information together, the large was $5, the small was $3, and these are both snack packs. And they were yummy. That's not in there, but I'm just going to assume that's true. Now we need equations. First, we're going to have one that represents the number, the total number, and then we're going to have one that relates the total cost. So in our first equation, we know that the number of large snack packs plus the number of small snack packs equals 60 total snack packs sold. We also know that the total cost was $220. And so we got $5 times our large snack packs plus $3 times our small snack packs. And now we have a system of equations. Awesome. Now when I look at this guy, if I want to solve him, I can see that in this top right here, it's very easy to solve for x and y. So let's solve for y. I'm going to move this down just a little bit. To help me solve for y, I'm going to subtract x from both sides. So that tells me that y equals 60 minus x. So when I solve these equations, I'm going to start with y equals 60 minus x. I'm going to take this value for y, and I'm going to plug it into our next equation, 5x plus 3y equals 220. I can rewrite that second equation as 5x plus 3 times 60 minus x equals 220. Where did this 60 minus x come from? Well, that's equal to y. So it's totally okay that I switched them out. Okay, next we're going to distribute this 3 into 60 and minus x, giving us 5x plus 3 times 60 is 180 minus 3x equals 220. Next, I'll combine my 5x plus my 3x, which gives me a negative 3x, which gives me 2x plus 180 equals 220. Remember, since we're solving for x, we want to get it all by itself. So we subtract 180 from both sides. Continuing on, we have 2x equals 40. And in our last step, in a last-ditch effort to get x all by himself, we've got x equals 20 after dividing by 2. Cool. So x equals 20. What does this mean in the context of our problem? Well, remember that x meant the number of large snack packs sold. So that's the answer to the snack bar sold. How many large snack packs? They sold 20 large snack packs. Cool. Now, how are we going to figure out how many small snack packs they sold? Well, we can plug our value for x back into our equation up here. I like this guy right here. We have x plus y equals 60. We already know that x equals 20, so I'm going to get rid of that real quick. 20 plus y equals 60. Well, 20 plus what number is 60? It's 40. Or subtract 20 from both sides. Get y equals 40. So they sold 20 larges and 40 smalls. Fun, huh? Now, so far we've been using systems of equations that just have one solution. You can have one solution, as you can see. We just did that. You can have one solution. You can also have zero solutions, and you can have infinitely many solutions. We know this from graphing. Yesterday. Remember, as a quick review, when you had zero solutions, that's because you had the same slope. When you had one solution, it's because they intersected. And when you have infinitely many solutions, it's because they had the same slope and were the same line. AKA same line. We're going to do that same kind of deal here, except instead of graphing each line and seeing what happens, the best way to find the solution is to just solve for y. Because if you want to find out the slope, you want to find the y-intercept, just put it in y equals mx plus b form. That's what we're going to do. So here, let's solve for y for our first guy. Can I do it in this space? I think I can. You know what, I won't. Okay, I'm splitting my space into two sections. My first equation, I have x equals negative 2y plus 4. My second equation is 3.5x plus 7y equals 14. Now, in solving for y, I want to get y all by himself. So in our first equation, my first step is that. Subtract 4, we get x minus 4 equals negative 2y. And then we divide by negative 2 on both sides. This means dividing each of these terms by negative 2. So we get negative 1/2 x plus 2 equals y. Cool! We solved for y. Amazing. Let's do it again on the other side. I'm going to subtract 3.5x on both sides, giving me 7y equals negative 3.5x plus 14. And then I'll divide by 7, divide everything by 7, yes, even you, to get y equals, oh hey, crazy, negative 1/2 x plus 2. Check it out, they're the same line. Negative 1/2 x plus 2, negative 1/2 x plus 2. Awesome. Since they are the same line, this means that there are infinitely many solutions. Check it out. Same line, infinitely many. That's infinity. Might be like infinitely many solutions. There. Not that. This. So this is infinitely many solutions because these graphs, the graphs representing these equations are the same line. Now on this side, this is going to be just a chunk easier because this one's already solved for y. Y equals 3x minus 11. Cool, let's just solve the other one for y then. So we've got y minus 3x equals negative 13. So I'm going to add 3x to both sides, giving me y equals 3x plus 13. So on this side, we have y equals 3x minus 11 and y equals 3x minus 13. But since they have the same slope, but different y-intercepts, there's not going to be any solutions. They have the same slope, which means these lines are parallel, and there is no point that lies on both of these lines. So there's just no point to this problem, but there is a point because lines represent an infinite number of points. But in this case, there is no one point that is a solution, so this has no solution. Ah. Oh well. Okay. So to find the number of solutions, you just need to solve for y and look at their slopes. If they have different slopes, by the way, they would intersect. And then you should write that down. Intersect means different slopes. Cool. Now what if, when you're setting up a problem, you need to define your variables, write your equations, and then solve. And the way you solve by substitution is you need to solve for one variable, plug it into the other equation, and solve for the other variable, just like this. And most important thing, have a great time on your homework.